welcome to the first VPH TUT presented by the African Fellows. I'd like to just discuss the basic concepts that you learn in the beginning of physiology. In a sense, this is a physiology TUT, right? So let's first talk about the intracellular fluid and the extracellular fluid, okay? It's a very important ratio to remember, the 5:3 for the intracellular fluid to the extracellular fluid. Because there's more cells in the body, so more of the fluid is in the cells, right? Now we can further divide these two compartments into intravascular and extravascular, which is essentially dividing the body cells and the blood cells and those compartments. So for example, the intracellular fluid in the intravascular compartment is going to be the fluid inside the cells that are in the vessels, the blood vessels, right? So just remember those classifications and the ratio. Alright, now moving along to the composition of the extracellular fluid and the intracellular fluid. So these are very important, I wouldn't say values, I'd just say concepts maybe to remember. So in the extracellular fluid you have a higher concentration of sodium ions and chloride ions. But in the intracellular fluid, you have a high concentration of potassium ions, okay? So essentially, if we look at it as a cell, if this is our cell, inside the cell we have a high concentration of potassium ions. And outside the cell, we have a high concentration of sodium ions. Now, the reason I mentioned the chloride ions up there, they're not too important to know for now, but just an easy way to help you remember what's in the intracellular fluid and extracellular fluid is that you can think of it in a way like the extracellular fluid is kind of frustrated because, you know, it has FOMO, it wants to be inside the cells, so it is salty. Alright, yes, I came up with that myself. Anyway, moving on. Okay, so this concept, this vision is what you need to keep in your mind all the time because it's going to come up when it comes to membrane potentials, action potentials, pretty much everything, okay? So according to the diffusion gradients, naturally substances will move from where there's a high concentration to where there's low concentration. So naturally the potassium ions are going to move out of the cell, alright? Just by passive diffusion, okay? And when a substance or something moves out of a cell, we call it efflux, okay? Efflux, alright? Apologize for my handwriting, but anyway. And then the sodium ions are going to move into the cell, alright? And when something is moving into a cell, we call that influx. Now the means by which these ions move is just your simple leak channels, but we'll discuss channels a bit more just now. But it's just incredibly important to remember what happens naturally in the cell, where ions are moving without any energy. And just a note to remember for future, this is where your sodium-potassium pump will come in, because your sodium-potassium pump is there to try and keep this balance of a high concentration of potassium in the cell and a high concentration of sodium out of the cell. So because you know that the sodium-potassium pump uses energy, ATP, you're going to know that it's going to be working against the diffusion gradient, right? So what your sodium-potassium pump is going to do is it's going to pump the K+ ions back into the cell and the sodium ions out of the cell. But that's just something for you to remember for a later time.